In this video, we're going to talk about two concepts, blocking and the simple mistakes that you can make in an experiment. So first things first, let's talk about blocking. So, I mean, just based on common sense, we define blocking as to put samples in more similar units, and each unit we call a block or subset, and to compare them with each other. Just to make more sense of this process, let's go back and look at the randomization process that I mentioned to you. So let's say, so we knew that we could control temperature from 100 degrees C all the way to 200 degrees C within a very narrow range we could control it. But the time we were dealing with was between 1 and 5 hours. And so we used the randomization process to avoid this, so that this doesn't get into our measurements. But now let's say, and this was one block, it's what composites in this range and this range. But now what we can do is we can split this block into two blocks. One in which time varies between 1 and 3 hours, the other one time varies between 3 and 5. Or we can even split it into 3 blocks. That's 1 to 2 hours, 2 to 4 hours, and 4 to 5 hours. Within each of the blocks, the variation in time will be very small, so the data within each will be more similar to each other, and that allows us to more reliably compare data and extract information out of the data. So now if I go back to this, so now we have two samples, in the same blocks. They're getting in the same block. That, let's say we keep the time within 1 to 2 hours. They get different treatments, that is, the temperature is changing. But because this is a narrow range, we will have less variation due to time or duration of curing, and we can focus on temperature of curing to more precisely get the trends. So here, when I'm putting them in smaller blocks, two things are happening. One is because I am limiting the variation of one of the variables, or the range of variation of one of the variables, my comparison is more fair in terms of I know that the change due to time is very limited, partly because the change in time itself or duration itself is very limited. So then I can more reliably focus on what temperature does to my sample. So this becomes a fair comparison. And so if it's very, if you make these branching or blocking and splitting blocks into more blocks, you can make this fairer and fairer and fairer. However, the cost is you're increasing the number of experiments. So now that I have between 1 and 3 hours and 3 to 5, instead of just putting 1 to 5 in one category, hour, I am doubling the experiments in this case, but at the same time, I'm getting more information. So depending on how my data is sensitive to time, I can decide whether I need to do this splitting or not. If the data is not that much sensitive to time, by going this way, I'm definitely doubling the cost, but the payoff is not going to be doubled because the data is not sensitive to time. If the data is very sensitive to time, then that could be beneficial. In some cases, if it's very, very sensitive, then that's the way to go. Otherwise, you'll have so much variation that the data becomes meaningless. There's no trend that can be extracted from it. So now, based on these partly related to the blocking, there are some errors that can happen in an experiment. If the variation in temperature has a significant effect on the outcome, then you're introducing a lot of error in your measurements. If you have variation in your inputs versus variations in the measurements, then you have to take them into account as well. If the temperature is a very important parameter and you don't control it and you go with randomization, you're not going to get good results. So there, when we control temperature, and we treated T as a random variable, we assume T is far more important in influencing the strength. But if T is the lowercase t, the time is a more important variable, then you have a problem. And in that case, you have to revise your whole experiment, and your control variable is actually becomes the factor. The other thing is fail to isolating effects of different factors. For instance, if the type of processing that you do, if the way you make the samples, or if the geometry of the sample is an important parameter, then testing on different geometries or different sizes can give you different results. And so you have to be very mindful about other factors that you don't take into account that can be important. For instance, another example I can give you is the epoxies we use. Sometimes, a lot of times, they're two-part epoxies, just like a two-part glue that you can buy from Walgreens. It's a very similar concept, by the way. And the ratio of those two are important. So then I'm adding another variable here, which is the ratio of one part to the other, or resin to hardener. If this ratio is not controlled well, then you may get some randomness in your measurements, and you don't know whether it's coming from this guy, or this guy. These are the things you have to consider in the experiments. The mistakes in experiments continues in the next video.